In this podcast episode, host and evolutionary biologist Scott Solomon explores the profound ways in which human life on Mars could transform our biology, psychology, and culture. The discussion covers NASA's Mars analog experiments, the physiological and psychological challenges of spaceflight, the evolutionary implications of living off Earth, reproduction in altered environments, and the ethical and political complexities of establishing a human presence on another planet. Scott begins by describing NASA's CHAPIA experiment, a Mars habitat simulation at the Johnson Space Center in Houston, where crews live inside 3D printed mock-ups designed to replicate life on Mars. The current study aims for a full year of confinement to help understand what it would be like for humans living in such an extreme and isolated environment. These analog missions focus heavily on the psychology of people stuck in confined spaces with limited resources and restricted movement, since physical factors like Mars's reduced gravity and high radiation cannot be fully simulated on Earth. Through these experiments, researchers gather data on group dynamics, mental health, and logistical challenges in preparation for eventual Mars missions. Solomon explains that spaceflight brings significant physiological changes due to microgravity, including muscle atrophy, bone density loss, fluid redistribution resulting in space face, and reduced blood volume, which can cause anemia upon return to Earth. These effects are still not entirely reversible. Radiation exposure poses additional risks beyond low Earth orbit, where astronauts are protected by Earth's magnetosphere. Deep space radiation, cosmic rays, and solar particles can damage DNA and impair cognitive function, leading to phenomena towards space fog or space brain. Psychological challenges also arise from isolation, confinement, and the inability to leave, creating pressures on mental health and group cohesion. Exercise countermeasures, mental health support, and habitat design are essential but cannot fully mitigate these effects. The discussion shifts toward evolutionary biology and how long-term Mars colonization will likely lead to significant biological divergence. Solomon outlines that if humans live there for multiple generations, raising families and reproducing, natural selection will act differently due to Mars' unique conditions of lower gravity, increased radiation, reduced microbial exposure, and limited resources. This resembles island biogeography dynamics, where isolated populations undergo rapid evolutionary change through founder effects and bottlenecks. Historical analogs, such as the Homo floresiensis population on Indonesia's Flores Island, show how restricted environments can produce distinct physical adaptations. Living on Mars will accelerate human evolution, producing genetically and physiologically different descendants. Landing on Mars after months in zero gravity poses serious physical challenges. Astronauts transitioning from weightlessness to Mars' one-third gravity must readapt muscles, bones, circulation, and balance systems. Radiation exposure, greater than on the ISS, elevates mutation rates and cancer risks, compounding health hazards on long-term missions. Mars' thin atmosphere offers little protection, increasing vulnerability to meteor impacts and environmental extremes. Solomon stresses that even advanced habitat designs cannot fully shield inhabitants, especially if Mars walks and outside activity are necessary for survival, accelerating bodily deterioration and mutation load. Sustaining human life on Mars requires overcoming food production difficulties. Currently, astronauts rely mostly on shelf-stable, freeze-dried foods. Fresh produce is rare and highly valued, as illustrated by the story of a contraband onion on the Russian space station, cherished as a birthday gift. Growing plants on space stations has been limited to experimental scales, and expanding agriculture in Martian habitats remains a critical hurdle. Without diverse, fresh nutrition, physical and psychological health will suffer, further complicating long-term habitation. Drawing parallels to Antarctic research stations and submarine crews, Solomon notes that success in confined, extreme spaces demands specific psychological traits such as openness, good communication, and cooperative teamwork. Odd-numbered crews help avoid factional splits. Previous selection criteria for astronauts, often limited to highly trained military test pilots, would not suffice for founding a genetically diverse, psychologically robust Mars population. He highlights that social cohesion is vital, as small communities magnify interpersonal conflicts and mistakes. The lack of privacy, communication delays with Earth, and absence of natural environments will intensify psychological stress. Solomon emphasizes that political governance of Mars colonies cannot simply be Earth governments extending control. Long communication delays make direct oversight impractical. Effective leadership must emerge locally, with skin in the game. The idea that Mars offers a fresh start free of Earth's political flaws is unrealistic, as human nature and its complexities will persist. Legal frameworks for crimes, governance, and interplanetary relations will need creative solutions to prevent fragmentation and allow collective survival. The potential for oligarchies or inequitable power dynamics raises cautionary concerns. Astronauts frequently describe the overview effect, a profound psychological shift upon seeing Earth from space. This experience often deepens appreciation for planetary fragility and unity. While inspiring, Solomon notes that this shift may not transfer fully to descendants born on Mars, who will develop a distinct identity separate from Earth. The social isolation and environmental constraints may diminish this connectedness over generations. One of the largest unknowns is how reduced gravity and radiation affect human reproduction, pregnancy, and fetal development. Animal studies remain inconclusive, and no documented human sexual activity or childbirth has occurred in space. The physical toll on adult females living their entire lives in one-third gravity, such as weakened pelvic bones, childbirth risky or impossible without surgical interventions like C-sections. Changes to birth processes could alter evolutionary pressures on human physiology with unclear long-term outcomes. Assisted reproduction and genetic technologies may become necessary to ensure survival. Speciation, the formation of new species, may occur faster on Mars due to isolation, environmental pressures, and restricted gene flow with Earth populations. Psychological, cultural, and microbial differences will also increase divergence. For example, children born on Mars will have microbiomes shaped by a small subset of earthly microbes, creating unique immune challenges. Quarantine protocols may become essential to prevent harmful cross-contamination between Earth and Martian settlers. These forces will accelerate differentiation, eventually producing distinct human lineages. Mars colonists will inevitably develop their own culture, language nuances, and traditions shaped by scarcity, confinement, dependence on technology, and environmental constraints. Solomon reflects on how human culture rapidly adapts when groups move to new environments, highlighting the speed at which cultural divergence can occur. Over generations, Martian human nature might become unrecognizable, both biologically and culturally, compared to Earthbound humans. Solomon and the host grapple with the morality of sending humans, especially future generations, into a harsh, dangerous environment with many unknown risks. Is it ethical to knowingly expose children to elevated radiation, reproductive difficulties, and psychological challenges? If so, might genetic engineering be required to enhance their survival, raising profound ethical questions about altering humanity? The discussion underscores the complexity of balancing genetic enhancement against natural evolution and unaltered human identity, especially when descendants may lack freedom to leave. The conversation ends with a call for prioritizing biological, psychological, and social research before committing to long-term Mars colonization. Understanding reproduction, radiation effects, immune system challenges, and mental health is critical. Technological advances, such as in vitro gametogenesis and artificial wombs, might play a role in supplementing natural reproduction. Ultimately, while the motivations to expand humanity beyond Earth are clear, so are the challenges requiring careful scientific and ethical deliberation.